Hi everyone and welcome to this quick course on Bash scripting, one of the essential things to know when you're working on Linux. So, why Bash? Bash stands for Born Again Shell. Don't ask me why, it has got some history. It's been around for ages and it's been used mostly for automation, little like setup scripts you can use it for, and just general shell scripting. So, what we're going to learn, we're going to learn how to write and run Bash scripts, the Bash syntax from variables to functions, arrays, and how to work with command line arguments, and probably a bunch more. But I will keep everything short and concise, so that if you already know how to program, it should be easy to get through and learn the basics of Bash, and you can get started writing your own Bash scripts. So enjoy, and thank you very much for taking this course. Hi, and welcome to the first proper lecture on this Bash course. In this lecture, we'll be writing our first script. Let's start with the shebang. Kind of stands for a sharp bang. People just said it quicker and quicker and it became shebang. It's a hashtag and a exclamation point, or a pound sign and an exclamation point, just how you want to see it. Let's I think I have some scripts. I do, but not for this. So let's just get started with our hello.shell. So we first need to start with the shebang. This tells the computer which interpreter to use. In our case, for Bash shell scripting, it will almost always be bin bash. So with this, we can just say echo hello world. Echo is a command that prints to the output, the standard output. So we can quit this. Let's see, yeah, I have the script. So echo hello world to output hello world to the standard output. To make it executable, we need to change mod on this file. So we need to say we want to have executable permissions on this file. So let's do chmod plus x, which stands for executable. You can also use the 655 if you want to use octal, but I don't. And then we can run it with /hello.shell, right? So in the previous slide on the shebang, you might have noticed that I've said try bin python or even bin cat. And you might have noticed I've already used cat because I wanted to output a shell script. So we can set this interpreter to anything we want if we have it installed. So if I do test, does it exist, bin python, I don't have bin python. You can see it with the red caret right here. That tells me that the test has failed. So I don't have python, but of course I do have cat, right? I do have Python 3, by the way. So if I do this, Python 3, we can see that screen. So I have Python 3. So I have my python.shell right here, which uses the shebang of bin python 3. And it uses the Python print syntax. So I've already made it executable. So if I run python.sh, it will run hello Python. And it will run it as a Python script, even though it doesn't have the .py extension, and I don't have to say Python 3 python.shell, right? But you can pretty much use any program with this shebang, which is a lot of fun. So we can also say, let's use cat, which is of course the command to output a file's contents into the standard output. So if I run cat.sh, even though it's not really a shell script. What do you think is gonna happen? Do we only get to see hello? Do we get an error? No, we just get the output of the whole file. So that's what a shebang is, what it does, and how you can use it. But most of the times, and for sure in this course, we will only be using bin bash. We've already gone through this script. And then I want to congratulate you on writing your first bash script. And this is your first step into automating your Linux environment. Thank you for watching, and I'll see you in the next lecture. Hi, and welcome to the next lecture on bash scripting, variables. And it's not really that long of a lecture, but we can talk about it for a bit. So I don't have any other programs right here, but let's just copy our hello.shell to var.shell, right? And let's vim. We have our hello world. But of course you want to maybe greet a user, so we want to say hello user. Well, my user is called MB like this, I think, but we can also use our host name, which is just BC. But how do I do that? Because it's not the same for everyone, right? And I want to share my awesome scripts. So for this, we're gonna use variables. So to declare a variable, you just do something like this. So hello, and then my abbreviation. And oops. Then I can say, okay, output that abbreviation, please. If you didn't copy, be sure to do this, right? The change mod, because I have copied the script, I don't have to do it again. So we can see that it outputs my little name, right? But okay, so the general syntax of a variable is you declare it, you make sure there aren't any spaces between here, which sucks for readability, but it's pretty much required. The uppercase is not required, but it's good practice to do it anyway. And to use a variable, we use a $sign. And you might have noticed in the very, very first lecture that I did, the introduction, I used echo $shell. So shell is just a what's it called? A variable, an environment variable, right? And most of the times I have it on bin z shell, but it doesn't really matter, right? We can just change it and nothing really happens. So that's how we use a variable. But we also have some more options to use these. So of course I want to say hello user and not just hello and then another, like I don't want to hello and then hello var, but this will not work. I thought so. So we're learning new things every day. Because another way to use it is with these curly braces around them. And yeah, I just said I thought that it was required, but it isn't. But one way where this is useful is if you want to append some text to this, right? So for example, like whatever, I can just add this text right at the end of the variables text. But if I do this, then it thinks that this is a variable, and that's a variable that doesn't exist. So that's why you could use these curly braces. There we go. Like that's why you could use the curly braces. But you have already spotted something else in my slides right here on the left. And that is the $sign with parentheses. So, of course, parentheses are something else. So, this will not work. Var command not found. So, what does that tell us? That between these parentheses, we can run a command. So, hostname is a command, right? And it just prints PC because that's my host name. Very boring. But if I do this now, we can see that it executed a command. And because it's within these parentheses, we can use the output immediately and append some text right next to it. So, just to recap, welcome to Hostname's Awesome Course. As user, right? So this is how we can use variables and how we can execute commands and use that as well. Cool. So what is next? We have some special variables. And these special variables also always start with a $sign, of course. Let's just echo some of these, right? So, oops. $sign add. Okay, so we have 0, 1, 2, and @. Oops. So what does this? It just prints the command I used and some empty lines. But if we can read, we can see, okay, $0 is the script name, which is correct. It output the script name. And 1 through 9 are the command line arguments. We have given none. So $@, would of course also return nothing. So if I do this, we can see that our $1 will return the first command line argument, and so with 2, which is $2. And $add will return them all. And let's see if it goes further than 9. Yeah, it does. So if you have like a ton of command line arguments, which there's a lot of scripts that use more than 9 arguments, you can use the $add. And we will also be using this later on when we will be looping over things with loops. So thank you for watching this lecture on variables. There's a lot you can do with variables. There's some great built-in variables like 0 through 9 and the @. And we have seen how to use some Linux commands such as hostname, but you can do anything. You can also use the output of a command. So cat, like cat.sh, for example. Just put it between the parentheses and it should work. Right? Thank you for watching, and I'll see you in the next lecture. Now that we have taken a good look at variables, what variables are, how to use them, we can go into some basic input and output. Of course, we have covered output already with the echo command. So this lecture will be purely focused on input. So we can check for input with the read command line script or function, whatever you want to call it. I have a typo here, but we will check how it works in a second. So I have my input.sh, which will be just a script to greet the user. So my user is MBV, right? So I just say, okay, hello, and then the user, and this works. But what if I log out and another user logs in? Then they should change this to whatever their name is, right? Because otherwise it won't work. So how do we fix this? Well, we should get some input from the user. So we can do this with read and then a variable name that it will write the text to that it has read, right? So not Vim, I want to execute the script. If I execute it, it doesn't print anything. It's just output, but we can type here. And if I press enter, it will work correctly, like hello MBV or SAV, like whatever. So this is great, but I want to make it even better. I want to add a prompt, like ask the user what they should input, because in this way it's not really clear. So we do this with the -p flag, which probably stands for prompt. And then we can give it a string. So what's your name? We end with a space right here, because otherwise the text that you input would be right against the question mark, and that just doesn't look very good. So if I run this now, we can see what's your name. That looks a million times better already, right? So we can say MBV, hello MBV. So this is really everything you need to know for inputting text, at least in this stage of your bash journey. I've written some configuration scripts, like scripts that start configuring a certain project for you, that just uses this kind of read. And it works great, right? You just put it in a variable, and then you test it with the if statements, like what's the actual value that you've gotten. And then you can see, okay, so you prompt the user, do you want to do this? User says yes. Then you check, is the text yes or just the letter Y? And then you continue with configuring that part of your project. And it works great. So, in conclusion, inputs are pretty easy. You just need to remember, no code process. You just need to remember read -p, your prompt, and then your variable. Thank you for watching. Now that we have taken a look at getting some input from the user, we can use conditionals to further develop our configuration script, for example. Like, hey, do you want me to configure this? Yes or no? If yes, do this. Else, do that. Right? Simple if statement. All right. So how do we do that in Bash? In Bash, Bash uses the test command under the hood, which is a command that you run in a command line. So we can say test. I've used it in the first, like your first script texture, to test if I had a certain interpreter. Because I didn't have Python, I only had Python 3. And we can see that it outputs a either true or false, right? Because my carrots here are red or green, and we can test this with the true and false commands that also exist, right? So true, it's green, false, it's red. And we can see how test works and how we should use it by running man test, because it has a manual page. And it's big, it has a bunch of flags. So let's just -e to check what I've used before. Like, okay, we have EQ, which tests if two integers are equal. But if we go down, we also have -e with a file name. check if a file exists. Or -d is the directory. -f, is it a regular file, right? So there's a lot we can work with. But how do we use this in Bash? So I already have my test.sh, which will just get a simple input from the user. Like yes, yes or no. And then we can do things with this input. So let's start by telling it or asking it, all right, is this input equal to y? So let's just go into test and let's see right here. We have string equals string. Are they equal? And it's just a single equal sign with spaces between it. So it's not like most programming languages where it is two equal sign, right? So our variable called yes, is it equal to y? If so, then echo nice. And we end it with fi, which is the reverse of if you are wondering. So I don't have it right here. We can run it. If I input n, it doesn't do anything. If I do y, it prints nice. And that's exactly what we expected it to do. So if I want to add more conditionals to this, for example, all right, elif yes equals n. What do we want to do then? Echo boo. Like, that's not nice, right? So then we can say n and it will say boo. If I do y, it will say nice. If I do something else, it doesn't do anything. So let's fix that by adding a else to this. Echo wrong input, because you should probably input something that is either y or n. And if you put this in a loop, you can say something like, while the input is not equal to either y or n, keep asking, right? Let's write and quit. Let's write it. If I do L now, it will say wrong input. But still, if you do y or n, it will be nice or boo. Let's see what my next slide is. We've already covered it. We can run man test to check what options we have for like integers. But I also want to mention something final right here. A lot of people will format their functions like this. They add the semicolon and then they add the then keyword on the same line. Because let's be honest, this makes it a whole lot more readable. And readability in Bash or shell scripts in general is kind of an issue, right? It's not the best looking programming language. So small things like these, if we can fix them, you probably should. But just keep in mind that you don't have to. Because this is a single line of code. We have to end it with the semicolon. So Bash knows, okay, I need to start like, I need to start like a new line right here, right? Just keep that in mind, but this is way cleaner. So just to conclude, these square brackets basically mean that we are using test. So this is similar to yes equals y. Just keep that in mind. Thank you for watching. Now that we've taken a look at some conditionals, we can take a look at the next kind of conditionals, the switch cases. The basic syntax of a switch case looks like this. I personally really do not like it. It looks a little bit weird, but it just is how it is. So case and then a variable or a value in. So if the value is in pattern or pattern 2, then we will execute the commands. As you can see, we end a pattern with a closing semicolon or semicolon parentheses, and we end the statements that we want to run with a double semicolon. We close the whole switch case with exec, which is just case backwards. It looks a bit weird, but you know, that's bash. So you can have these patterns. They can be regex or they can be a wildcard for all the other cases, right? So in this case, we would have a certain input, like you would prompt the user if they want to install a program, yes or no. Then you would probably have something like this. It could either be a lowercase or uppercase n, or lowercase or uppercase y. And if it's neither, then you don't really know what the user wants. So you need to prompt them like, hey, what is it that you want from me, right? So let's create a example. I have already created my case.sh, so we will create case 2. So let's start with, of course, the shebang and just prompt really simple yes or no. Then we want, then of course we want to read this into a line. So let's do this so we can actually execute it. Case 2. So yes or no. No, nothing happens, but this is the first step, right? So right here we would say, okay, we want to check the value of line, which we get here, right? And is it either yes, then we want to echo yes. Of course, in a real script, you would actually do something right here instead of just echoing. And no. Let's close it. And right here we would say, please enter y or n. And of course we have to close it with exec. So this looks like a proper shell script for doing something like this. If I enter p, it of course will not work. If I enter y, it will print yes, or n, it will enter no. But what if your users are either very smart or dumb, depending on how you look at it, things, and they enter yes? Then of course you would get the question like, okay, please enter y or no. So we can actually make this script a tiny bit better by just adding 3 more of these little patterns, right? So right here we say, okay, this pattern can either be just a single y or the full word yes. Oops, sorry. Or the full word yes, but we do not care if it is lower or uppercase. And we would do the same with no, like so. So right now, if I do n, it would do no. If I type no, it will also do no. But if I do yay instead of yes or y, it would still fail. You could of course make it bigger by also accepting this, but you know, this is kind of how it works, right? You can use the default regex things that you can use in bash for your switch cases. So in conclusion, a switch case can be very useful. The syntax is a little bit weird, but even if you have to look it up once or twice, you will pretty quickly get the hang of it. And you will be able to use this a lot, actually, in your programs. Now that we've taken a look at conditionals, we can take a look at loops, right? Which are just fancy conditionals, because we can create loops with recursion if we have conditionals and functions, which we will get into. But for now, let's get into a for loop. So I have my loop.sh, which is empty for now. And right here we can use a expression like this. So we just say for I in a sequence, and this sequence under the hood probably uses something called seg or sequence, and it's just something like this. So let's output this. It's just 1 through 5, which is probably what we expect. And let's test if it actually is the same. So I think I did something like this. Yeah, it's exactly the same. Which is great, because now we have some loops and we can loop over things, and we can make a sequence dynamically if we really want. So you can say length is 5, and then we can say length, and then we can output 1 through 5 again. So this is great, right? So with this we have a very simple for loop. And again, I should reiterate that you can make this more readable with the semicolon and then putting the do on the same line. And keep in mind that it's for I in whatever do and not if then, and it's done and not vi or something like rough or whatever. So the simple for loop. We also have another classic, the while loop, and these are a bit more annoying in Bash. Let's skip our uppercase for now because I forgot, and let's write one. But hey, we've already seen these square brackets before. It's our dear old friend test. So while count is less than or equal, which is one that we have seen before when we ran man test, right? If I do LE, we can see integer 1 is less than or equal integer 2. And then we again can do this to make it more readable. Echo the count, and then we're done. But wait, this will create an infinite loop. So I need to update the count. And Bash is a bit annoying in this sense. We need to use a arithmetic expression, which is a $sign with double parentheses. And then we can say count plus 1. Because otherwise it will complain that the plus command is not found, because it will try to execute it as a command. But if I do this, I should be able to just output 1 through 5, which is just 1 through 5 again. And that's great. So one thing we can also do is we can use break. So if then if I, let's just say if count is greater than 2, then we will break. So if I run this now, I will only get 1 through 3, right? And we also have our, sorry if the bell rings on the background. We also have our continue statement, which will just skip the rest of the iteration and go through the next iteration of the loop. Which is, it would require a bit more boilerplate to properly show it, but that's what it does. So let's go back to the for loop and check our $@ so do done echo I. The $@ will return the list of command line arguments, which we have seen before. So if I do this and then 1, 3, and 5, it will print 1, 3, 5, and I can do this like however long I want, right? So keep in mind that that is one thing that's available to you, because it can be very useful if you have a shell script like sum, right? Where you want to increase the number by every number that you input, right? You want to create the sum of a list of numbers, or the average, right? Which probably is a good exercise, so go ahead and try it. We also have some arrays, which I will not get into very deeply, because arrays are a bit janky. If you want to loop over the array, you would need to get the length of the array, which looks something like this, like length equals to, like it's janky, right? So we have array, which is a list without commas, and let's just say, okay, echo length, right? Will this work? 3, yes. And then you would have to use this with a regular for loop. So again, with it's pretty not great. So something like this, but of course it's a $. Let's see. I in this case is not a $. I have Stack Overflow open on my other screen. It's just something like this is the for loop that you want, and then echo. Let's see. Array I. Oops, I think. Done. Yeah, so it's pretty not great, but it exists and it's pretty useful. And if you create a script once, you will never have to look at it again, which of course is something that you want to do, because it is done for not reproducibility, but ease of use and not ease of programming. So for some reason this doesn't want to close, but that's fine because we are done anyway. This lecture was a bit longer because loops can be pretty annoying in Bash, like you've seen with looping over the array. But it can also be pretty easy, like you've seen with looping over a sequence of numbers. So thank you for watching. So right now we haven't really encountered any duplicate code, but any programmer will know that duplicate code is very annoying to deal with, and you should probably deal with it sooner rather than later, because if you keep copying code, you will keep increasing the size of your code and decrease its readability. And that's where functions come in, because every programming language is not complete without functions. So the syntax is very similar to other languages, right? So I have my func.sh. Let's just say name, and then we echo wow, and we call it with name. So if I do func right now, we can see that it will output wow. And if I do name, we can see it's even more impressed. So how do the variables work? So the variables are a bit janky, I should say. So if I do something like this, we see that we don't get an error like you would in most programming languages. And we should do something like this. It would be the first. So bad substitution. Okay. Bad substitution. Like this then. All right. So we can see that we should be using again these $1 through 9, and you could also use the $@. And in my opinion, that's not really great. It's like it's better than nothing, but it's hard to keep track of what variables and what parameters there are available to you. So we can just echo $2 and do something like this, and then we can see it would just output it, right? So again, it's very similar to other languages, and for a simple script you don't really need it, but keep in mind that it has its quirks related to the parameters. But other than that, it's useful to have functions in this language like any other language. Thank you for watching. Doing math in Bash is pretty weird. So let's take a look at why it is weird, or at least how it works. So what makes it weird? You have these arithmetic evaluations or expansions that you need to do, because you cannot just do like x is 1 plus 1. That won't work. So you need to know this syntax, like with the double parentheses. Bash as a language supports plus, minus, multiply, divide, modulo, and power, like 2 to the power of 2, for example. So there are also, if you have read some other scripts, some outdated ways to do math. With these let expressions, you can say, okay, total equals 100 plus 50, and it still works. Like 100 plus 66. And then if we do echo total, we get 166, like you would expect. So it still works, but it's an outdated way to do these math expressions. The same with these expressions. It's also an outdated way to do math. But since they have existed, and you might see them in other people's shell scripts, it's useful to know that they were a thing in the past. So I have some quick demos. I have mathprint shell or .shell, which is just a count which gets set and then printed, and another evaluation, or like this one is an expansion, so this one gets outputted, I guess, while this one just does this but doesn't give any output. So if we do math.shell, we can see 8 and 16 like you would expect. Let's do it like this to make it a bit more clear. Like 8 and 16 like you would expect. But if I change this, for example, like this, we get a command not found, because of course we don't do anything right here, right? So it tries to check for a command called 8, I think. Yeah, 8, command not found. But if we remove this, it will just execute this and set the count to 5 plus 3, which is of course in a variable called count. And in the second one, this actually gets expanded into count plus 2, so, or times 2, which is 8 times 2 is 16. So that is kind of like how this works and what the difference are between these two. And I also have a counter.shell, which is just a very simple counter, a very simple while loop that will just count from 10 to 0. And if I run this, it's not very interesting, right? It will just count from 10 back to 1 or 0 and echo go at the end. Easy. But like you can see here, we do not use the $sign. We just use the evaluation. And right here we also use the evaluation because we don't need to expand it. We have this seconds in a variable right here. So we don't need any expansion in this script. So again, in conclusion, math in Bash is pretty weird, and you need to be aware of that it is a weird thing. So don't give yourself a hard time if you need to look it up when you are working with some of these things, because it's just very different than most other languages. Welcome to this lecture about wildcards. Wildcards are basically special characters that can expand into a lot of different things. And there are a few things regarding wildcards that you should be aware of when writing scripts. I will show pretty much all of these just by using commands like ls, but you can of course use them in Bash scripts as well. So the first thing that I want to show you is globbing, which is a pretty weird word to use, but it's a pretty useful thing to know that it exists. If I do ls right here in my Bash course, you can see some spoilers on lectures that you will get in the future and some scripts that I've written from for them. But of course you can see all these markdown files, the shell files, folders, everything. Let's say I only want to see all the shell files. Then I can just glob with a *.sh, which will give me all the shell scripts or everything that ends with .sh. If I add another star, in this case nothing really happens because I don't have sh, for example, right? But if you have a very, very keen eye, you might have noticed that I have a folder right here called test. And if I do ls test, we can see that inside of test we have test.sh. But, well, okay, I have a test.sh here, but that is this one, not the one that's inside the test directory. So what if I want to include that one as well? Then I can glob with a double asterisk, and I can say, okay, get every shell script from this directory or any deeper directories. So ls asterisk asterisk slash asterisk dot shell. You can see that we get pretty much the same as above, but we also get test slash test.sh. And if it was deeper, then it would also do that. So let's continue with some question marks. Because if I do ls, you can see right here that we have a, I don't know if it's really the extension, but a fish shell, z shell, and we have a CSV file. So what if I want to get all these like other kind of shell scripts? Then I want to get every shell script, so I start with the asterisk because I'm only interested in altering or in what is in the file extension. Then I can use a question mark sh. Then we get fsh and zsh. But I don't get the sh in this case. But what if I'm only interested in every file with a 3-letter file extension? Then I can just use 3 question marks. So a question mark can be any single character, right? A star can be any number of any characters, but a question mark is always just a single character. But that is not all that we can do. We can also use patterns. So, and this first example is really weird. I only want to get cat.sh and env.sh. Then I could do something like this. Like for each place of the letter, I can say, okay, it needs to start with this, then this, and then this. This will only like print out these two. But I can also say something like, okay, I want every shell script that starts with the letter E. Then I could do something like this. Or a final example with these patterns. If I do ls, you can see right here that I have case2.sh. But I'm not interested in that. The only thing that I want is I want to have any number of characters from A to Z that ends in sh. So I am not using any numbers right here, right? So you can see that this case2.sh does not come up here. And I think, but maybe it's not right here. Yeah, I can do something like this to signify, hey, I can do any character or any alphanumeric character. And if, for whatever reason, I don't have an example of this right now, you need to escape any character like these brackets, then you can do so with a backslash, of course. So how could you use this in a bash script? Well, I have just this simple example for you. For file in any shell script, do echo the file name. And then you can see all the shell script names get echoed, outputted, executed, or not executed, just outputted. So this is how you could use this globbing or these patterns, whatever, in here. Because of course we can also say, okay, every a.z, and we do not get the case2.sh. So in conclusion, wildcards can be pretty powerful, they can be useful, and they can be pretty fun, because if you are working with a very specific pattern, it is always a great feeling when it finally works. Thank you for watching. Hi, and welcome on this next lecture on status codes. You might remember that in a few lectures already I have mentioned the colors of these carrots, right? Of these arrows on the side of my screen. Let's see if I can zoom in a little bit more, not too much because we need to be able to read. If the previous command was successful, it will return something good, like a status code that is what we expect, right? But if it's red, then the previous command has either failed or it just means that something was not found. Like when we did test E and then bin nothing, I get a red arrow because nothing is not a command that I have in my bin folder, right? But if I do test E for bin bash, which we have been using all the time, we can see that the arrow is green. So somehow bash will do these things, which my prompt, which is starship, will recognize and tell me like, hey, something went either right or wrong. So why status codes? Well, status codes, like the way they are, go back like a lot of years, right? But they're still widely used in every program. And you might even recognize the status codes from programming languages like C, where you have like your int main, right? And here you do like your whatever, and then you say return 0, which is just like your basic boilerplate, right? But this is just a status code, like you would have them in Bash. So you can also use status codes, which we have now seen are numbers, to signify what went wrong. And another program or your documentation can use that to tell the user like, hey, this is the status code, and that means that this went wrong. So how to status code, right? Let's copy, I guess, test to status.sh, and let's open that. Okay, so let's, oops, I pressed F1, so the help opened. It's all kinds of bad. So in Bash you use the exit keyword. So if something went right, so if the user said yes, then we can exit with 0. If they did something wrong, or if they say no, we can exit with 1. And if they simply entered a wrong input, we can say -1. And then in our documentation we could say like, hey, -1 meant that your input was bad, and all positive status codes will mean that you just simply said no, right? So let's execute this. So status no, and we have a red arrow right here. But if I do yes, we can see that the arrow is green. And if I just type nonsense, we can see that the arrow again is red. So it looks like every non-zero code is a bad code. And that's exactly how it is. 0 is good, not 0 is bad. And whether that is positive or negative, it doesn't matter, right? And to program this, we use the exit keyword in Bash. So let's just open our script again, status, and let's just do something like this. So let's kill this as well, and we will say test e bin bash, and then exit with the previous status code. So the status code of this command, this should be. So bin bash, we have it, right? So that is positive. But if I do Python, which I don't have, I only have Python 3, remember? Whoops. And we do this, we can see that it's red, because it takes the status code from the previous command, in this case test, and it will return with that status code. So in this case it's non-zero. And we can also echo this as well. And I think that maybe it will even return a positive status code or a 0 status code, because the echo is successful. And as you can see, that's true. So you need to keep that in mind. If you really want to, you should probably do something like this. like right is, did it go right? And then right here you want to use that variable, because otherwise you would always echo and then the echo was successful, so you know it will return a 0 status code if you don't want to. So keep that in mind. But that's basically how you use status codes and what they are and how they're used. And you can see that even my prompt uses those status codes. Thank you for watching. Now that we have taken a look at a lot of things already, we can take a look at pipes. And pipes are, besides just bash scripts, very useful for general terminal productivity. So what are pipes? Pipes, in short, just connect the output of a command to the input of a next command. This is very useful for some simple one-liners that you can use, or just for searching in your file system, for example. So right here I have my ls. We could make it a list and do ls-l. Let's make this a tiny bit smaller so it's a bit more readable. So we have this list then, right? But what if we only want the shell scripts? Then we can pipe it with the vertical dash character, I guess, the pipe character. And we can put it into grep and we can say, is it like this? I don't know. Alright, I forgot. Then we can pipe it into grep, which will just search for a string or a substring. And we can say, okay, check for everything with the .sh extension. And then we can see it outputs all of these. And we can even sort it with, if we pipe that result again to sort. So here we start with cat as .sh, func.sh, which is, I think, on, not even on date, but it's sorted in some way, right? Maybe just by name or whatever. But if we pipe it to sort, we can see that it will sort it again for us. So now it starts with loop, and it also kills the highlight, but that's fine. We can do dash h. So if I do sort help, we see a lot of things. So human numeric sort, we can ignore cases, we can reverse it, which is good. So instead of starting with function input status, so we do loop test cat, and then we end with status input and function, right? So like this, we just output ls, which will list all the files. We pipe it into grep to search for all the files that have .sh in their name. If you have something weird like files that for whatever reason have .sh in the middle, like for example Angular files, you can have a app.component.ts. So you can have some like issues with that, because if it finds .sh, doesn't matter where, it will return that line. But there's more you can do. You can pipe it to set if you know how to work with that, or to awk if you know how to work with that. And you can do all kinds of fun things with this. You can cat a log, for example, or a file. Let's see. We have like our func, and then we can just grab our. Okay, that doesn't work, unfortunately. We can grab our shebang, which it doesn't like, probably because it is escaping those characters. Yeah, so we need to escape the exclamation mark, but we can grab like our shebang, right? And these are just very simple examples of what you can do with piping. but you can create some very powerful one-liners. Just ask ChatGPT, for example, to give you a list of some fun one-liners to try, right? With the find command, with cat, or like disk usage with df. You can do a lot of things. Now that we have had a lecture on pipes, we can talk about some fancy pipes or advanced redirection. These things are useful when writing some more advanced bash scripts or while reading other people's bash scripts. It's important to know that this is something that exists, so that if you see the syntax, that you will know, like, okay, this kind of makes sense now, right? So to begin this lecture, we need to talk about file descriptors, which are just files that your system has open. So if you open a file, like for example, you want to read some lines in a file, or in Vim, for example, it will open a file descriptor, and that file descriptor will have a number. And this number, if I'm not mistaken, will start at 3, because 0, 1, and 2 are reserved for the standard input, output, and error. So that's what the numbers that we are about to see mean and why they are what they are. So we can do some cool things. We can, for example, mute errors. So for example, if I do non-existent, you can see that we get an error. But if I pipe it to dev null, we don't get anything. So with this, I say redirect the output that goes to file descriptor 2 or standard error, and just move it to dev null, which, if you know something about Linux, is just something that doesn't exist. But you might be able to see we still get the status code, right? We still have the red arrow. So what we can also do is we can do ls. Okay, fine, it works. But we can just pipe that to dev null, and then we get nothing. And if we do this, it will be the same, because we will pipe just the first thing to dev null. So that's what this means. And you might see something that looks like this. So let's just do get input. And 1. This is very similar. This ampersand more than works in bash 4 and higher. So if you have a very old version, for example, or you are reading some old scripts, you might encounter something that looks like this. Just keep that in mind. And that's also why I wanted to show you this, because when you see things like that, it's kind of weird, right? Like the syntax looks weird, and you really need to know what it means for it to make sense. And while I have you here and I'm talking about like piping and outputting, we can also talk about the caret and the more than and the more than, or I will just call it arrow. So we have all these files, right? Let's just grab tmp. We don't have any temporary files in this directory, but if I do cat and then cat.sh, because it's funny, and we arrow that into tmp, and we do this, we can see we have tmp, and it has the input or the contents of our cat.sh. And if I run it again, we can see that it still has. But if I do this, it should have appended it to the end of the file. So if you ever want to write some logs, use arrow, right? And with these arrows, you can of course also use the what's it called? The file descriptors, if you want. So keep that in mind when reading somebody else's shell scripts, that this is a thing that exists. It has a bit of a weird syntax, but it's useful. And just like piping, for example, just getting rid of errors by piping it to def null or outputting it to def null, it's good to know, and it can be very useful, and you will see it a lot. Thank you for watching. Now that we have taken a good look at how to create shell scripts, let's also take a good look at how to debug them. Why should you debug your shell scripts beyond the obvious? Some scripts will fail pretty silently by default. If I do an ls on a folder that doesn't exist, it will print out the error. But not all programs do so. Some will just create a exit code, and then you would have to do like something like this to something like this. It's this, by the way, to actually check what status code you're getting, and then you need to go into the documentation and check out what it means. And that's not really great. So one way to solve this is to sprinkle echo statements everywhere. But sometimes that doesn't work. And sometimes you will forget that they exist. And then you will have ugly debug echo statements in production, which I know we all have done in some way or another. So one way to do this, to properly debug, is by using X-traces. X-traces sound really cool, but they just print each command after the expansion, but before execution. So what is this expansion? If I do echo shell, it will expand into echo bin z shell. So this is what will be printed by this X-traces. And we can check this in a few ways. Let's clear this and let vim r or a echo.shell that I have prepared. It's just a shebang and a echo shell. So one way to do it is for the whole script. Then you need to add -x to your shebang. It will enable these X-traces for the whole script. So if I run this file, I can see this is the X-trace, and it's after the expansion because it shows echo bin z shell instead of echo $shell. But what if I have a really long program? I do not want to have these X-traces enabled for like the whole program. That's just absurd. So what you then can do is you can use these set statements to enable and disable these X-traces. And for me, it's kind of backwards that we use a dash to enable and a plus to disable, but that is just how it works. So right now, if I run this, we can see that we have these X-traces for my echo statement, but also my set statement, because they will be printed before execution. So this still gets executed, but it will also show that it has been done. So we also have verbose mode, which will show each line before it is expanded. So we will actually, or we can actually use verbose mode again in the shebang, but also with these set statements. There we go. And you can see, okay, it will show each and every line. So our shebang is executed or printed. The echo statement is printed before its expansion, so it shows the $shell, and then it is executed. And I should note that in a previous take I saw this. If I have like a white space, it will also print out that white space. So keep that in mind, that if you want to have this a bit more like readable, this verbose mode, you can use white lines. So in conclusion, of course we have made this example with an echo statement, but don't just debug with echo statements. Try and use the proper tools that Bash will give you. The first of these useful commands that we are going to take a look at is sed. And this is by no means a exhaustive course on sed. It's just the basics. Sed is pretty powerful and it has a lot to offer. But with these basics, you can already start using it in some pretty amazing shell scripts. So the basic syntax looks like this. You have like the sed command, then you have a string and a file. Of course, you can also pipe your output into sed and you can leave out the file, but this is how we will do it right now. I will show it in a second. We can do a substitute. If you have ever used Vim, this might look very similar because it is very similar. You have the S, then a pattern, the replacement, and some optional flags, which I will mention in a second. We can also delete certain lines. So if a pattern exists in a line, then we delete it. Or if a pattern exists in a line, we can insert some text after those lines, which is pretty cool. Let's take a very quick look to this. This is not the one I wanted. No, I did not leak anything, no worries. So I've created this .env.example, and it just has some like default credentials like email, password, a username, API version. Just imagine that this is, I don't know, for some kind of web app, and you have like for development purposes, you have some default credentials so that you don't have to log in every time. Or maybe these will be database credentials, right? For development purposes. Because of course in production you would do it in another way. Yeah, that's great. So right here, I can grab like everything that has a curly bracket in it. So we can see all the fields that need to be set, right? So grep also is useful for bash scripting, but it will mostly be useful for experimenting by yourself. So then we have this output, which we can pipe to sed. And in sed I can say, okay, I want to replace the username with what is actually my username. So we do s username dash, let's just do mbv. And since we pipe our output of the cat and the grep to sed, we can leave out the file name. And then we can see, okay, sed will output this for us, and it will say the username is equal to mbv. But if I do this cat command again, we can see that the original file has not changed. And we will see why in a second. Let's, instead of this, let's just check, okay, like this line with the username. I don't really care because we already have our email. Then we can just delete the line. Or maybe I want to add another field. Then we can use it's not a, it's a I. And then we can insert some text. So let's just test it with ASD. you can see that it looks pretty weird because you have to enter the text immediately after the I. So let's just say, okay, we have email, password, username, first name equals first underscore name. And then you can see that this just gets appended after the or before the username. So that's just how basic set will work. And then we have some useful things to know. These patterns, they can use some simple regex. You can also use extended regex with the -e flag, but I will not get into that in this course. I've also mentioned that we have some flags. We have the G flag, which stands for global. And I can actually show what that does pretty easily. So again, we have our set statement right here at the bottom. So okay, so let's say we want to substitute email for e-mail. Let's see. Okay, and you need to end it with a slash. There you can see that only the first occurrence has changed. So if I add this G flag at the end, it will actually update both occurrences. So you need to keep that in mind. You can also use a number to only update the first or the second or like the third occurrence of a pattern. So in this case with the flag 2, you can see that only the second one gets updated. We also have the I flag, which is probably what you would expect. It will just be case insensitive. So if you don't know if it is going to be uppercase, lowercase, title case, then you can use the I flag. And we can also use flags together, like G and I, to combine these functionalities. So we also have a command flag. So we don't put it in here, but we put it in here. This will actually change the file. So like I have shown, the file didn't get updated. But if I do this, no input files. Okay. Let's do it. Oops. Let's do it like this then. File was .env.example. And if I do .env.example right now, you can see that it has actually changed the original file. But we can do some more with this. So let's change email back to email. Let's check that. Okay. What we can also do is add a postfix. So let's do -i.back, right, for a backup maybe. And let's go back to e-mail. If I do ls-a, because of course they are hidden, we can see that this .back file gets created. And if I output that, we can see that it has not the emails. But why? I guess for some reason it really didn't find this string. I don't know exactly why, but with -i we can create a new file if we add a postfix. And this is of course pretty useful for some certain things if you want to like keep the original file. So in conclusion, set is pretty powerful for some simple text manipulation or just editing some files like this .env.example. But it is less powerful than awk, which is the tool that we will take a look at next. now that we have taken a look at set, let's look at awk for some more insane text manipulation. Again, this isn't a exhaustive course on awk. Awk is pretty powerful and pretty big, right? So if you want, there are some other amazing courses on set and awk, maybe combined with some other tools that you can find online or on Udemy or on YouTube. So why would you use awk instead of set then? So why learn both these tools? Well, first and foremost, awk is very great for tabular data. So for example, I have this users.csv file. If I make this a little bit tinier, it's just like a CSV file, right? But it's also way more powerful. It's almost like a full programming language. And we'll take a look at that in a moment, how powerful this can be. So its basic syntax, and I forgot a backtick here to close this. Its basic syntax is awk, and then between quotes a pattern, which is optional, like you can see here, and a action. And awk has some built-in functions like print. So we can print $1, which is the first column. This CSV file is not the best way to show this, and I will show you why in a second. Or I can tell you it's because these comma separated values don't work by default. Okay, so the first one is the file permissions, of course. If I pipe ls-l into awk, the last one, 9, is the file name. So awk can do more than just print out or change every line that you put into it. You can also just use a whole file and check for certain things and then give a certain output. So one of these things is if I do ls-la and we pipe this into awk, we can say, okay, $nf, which is one of these built-in variables. It's the number of fields. So nf will always be the final column. And we know that with ls-l, our final column 9, is the file name. So if my .env is present, I will simply print .env present. And I don't need to add a file because we pipe our output into it. And then you can see, okay, our .env is present. But if I do .config, it's not present because I don't have a file called .config. So this is just a very basic example again, in which we use the number of fields variable. We also have a line number. So this is useful for my CSV file. Let's see if I can make this a little bit better. It's not great, but it works for now. Of course, the first line of a CSV file is the headers in most cases. So I don't want those. So let's print everything after that. So we add a conditional, our number of our line number and r equals more than 1. Then we just print the whole line. And you can see we don't have this header. Of course, if you want, you can also say something like more than 10, and it will only show the last 5 or 6. I should say. So these are some simple things that you can do with awk. But for to work properly with these CSV files, you might have another separator, because by default awk will use a space character or white space as a separator, but my CSV file has these commas. So in this case, I should say something like uppercase F, comma. The comma is immediately after the F, which of course is a bit weird, but you know. And if I do print 1, then it will show the IDs. 2, I think, is the names. But if I don't use this, it will show this, because the only space it can find is before the last name of everyone. So that's why you would need to use a field separator for CSVs. But there is something more that we can do if we really want. We can create some pretty output with awk. And I will keep it very simple or fairly simple for this lecture, for this course, because I don't want to get too deep into awk, because you can easily fill like half an hour in lectures. So I have this command, which is a multi-line awk command. For every line after the first one of our users.csv, I want to add a object that is filled with the 6th column, which is the roles. So I want to count each role, so I do ++. Then we have a object filled with the number of occurrences of each role. And then at the end of the file, I simply want to loop over this object, and for each role in this counter object, I want to print the role and the count of the role. So this will be the key, and this will be the value. And if I run this, I get this pretty output. So we have 2 managers, 3 admins, and 10 users. And this is something that you really cannot possibly do with set. Or at least I would love to see anyone try. It might be possible, but not in a pretty way. So in conclusion, set and awk both are great tools. They do some slightly different things, but they both are powerful because they can edit files programmatically, where you need to have a user typing at the keyboard if you want to change anything in a file, like in Vim, for example. Set and awk can do these things programmatically, which can be very useful in these bash scripts. In this lecture, I will show how I would create the script that we make for our project. Or we have our .env.example file with this email, password, so on and so forth. Let's edit this very quickly because I don't want these, like so. We have this .env.example file, and I want to create a shell script that will prompt the user for their information, and it will copy this env example into a .env file and fill out these credentials. So how would we do this? I will quickly show my interpretation of this program. I've created my project.sh. The env is already present. Do we want to remove it? Yes. So we don't enter no, and we want to enter a email address. So mbv@example.com. Password. Welcome. And then if I cat my .env, we can see that it all has been entered, right? We have our email address that we have entered, our password, which is not very secure, and our username, which is just the first part of our email. This API version is something that we also add, but we don't prompt the user for it. But it is filled in our script. So if I again do this, we can see that the API version is not filled. Great. So, all right, so the first step was to check if our .env is even present, right? So for this, we can use a test. We can just use, test if the .env file exists. And if it does, then we need to say, okay, it is already present. So let's go step by step. I've called this, what have I called this, a file? I think it was env.shell. Okay, so I need to do this. There we go. Okay, so the env is already present, and if I remove it, oops, and I run this again, we can see that the env is not present at all. I don't know why my thing is giving this, but it's not. Yeah, sure. Okay, so the env is present. Let's ask remove. Yay or yes or no. Then we want to read our, let's just call it yes. And then we want to create a case, because that's the easiest thing, way I think, to check, okay, do you want to remove it? I only care about this. Okay, let's see. Okay, so let's just do a rm.env right here. And for any other, I would just want to exit. Like so. Right? So if the user really wants to remove it, they have to enter yes. Otherwise, it will not be removed. So, okay, nothing happens. If I add a .env, remove no, then it will prompt again. And if I want to remove it, okay. So that is the first part of our program finished, right? So now let's ask the user for some information. Let's say enter the info for the env, enter your email address, and let's read the email. Sorry, there was a hiccup. And let's echo this email. So let's run it. And let's echo it. Well, of course that works. So let's create this username. I think that username, yeah, it's already set. So let's just call it UN. And we want to do some magic here. So let's echo this email and pipe that into awk. And here we want to use a field separator of the @ sign, because we want to only get like the first part of the email, right? And then we would do print 1. So this looks really weird, probably, but it's pretty much like I have already explained. Okay, we have a error. So what is the error? Let's see. I can see it's the brackets. Sorry. There we go. So if I do it now, we can see that only the first part of the email gets echoed as our username. So password please, and then we read the password, which, if I'm not mistaken, is not a, like I would say, reserved. Nope. Great. So let's read the password. We know that that works because it's the same like we do here. And let's copy this .env.example into a file called .env. So let's run this, right? Enter our email address, asd@dsa, password's welcome, and let's cat our .env. It's still not filled, of course, but what do we want to do then? We want to do a search and replace on all these curly brackets, curly brace variables, right? So let's use set for this. We want to edit in place the .env file. Yeah, we can do it like this. Probably should do it like this, but oh no, I know why. I remember. Here we want to use double quotes because we want to use these variables that we have. Otherwise, these will just like get printed as a $sign email, for example. Let's copy this and let's replace email with password. I forgot the G flag, which in Vim also exists. Our username is called UN. And finally, we have our API version, which we can just call version 1. Like so. Alright, so we have a .env. Let's remove it. And let's run this shell. It's called env.shell. So enter the email address, mbv add example.com, a password, welcome, and that's that. So if I cat out the .env, we can see that it is filled with our email address. Our username is the first part of our email address. Our API version is filled, and our password that we have entered is filled. So in short, this is the whole project that we have created. It's a very simple shell script, but one that you can actually use on a job. So first, I'm sorry if you hear my cat, by the way. First, we check if the file exists, and if it already exists, we remove it, or we prompt the user if they want to remove it. And if so, we do so. Otherwise, we just exit because they shouldn't be in this program anymore because they don't want to overwrite their environment variables. So then we prompt the user for their information. We do some awk magic to get the first part of the email address. And then we use sed for some search and replacements. I hope that you might have created something very similar to this. If not, I hope you have learned something from following me creating this project. And I hope that you have a wonderful day. Thank you for watching. Hi, and welcome to the final lecture, the conclusion of this course. First of all, thank you again very much for choosing this course and following it until the end. We have learned a lot, and I hope that you will be able to create some great scripts for you, your coworkers, and your family. I don't know if you are like that kind of family. But what do you do now? So Bash still might feel like it's a bit of some niche knowledge, but the knowledge of Bash will help you in your Linux journey because it is so universal and widely available on any Linux distribution that it will not hurt to know anything about this. Like the same goes for Tmux, which is the environment that I have my multi-terminal setup in, or Vim, which is the editor that I've used, which is available on every Linux distribution, even on Mac OS. I think it's installed by default, right? So just keep that in mind. these scripts write once, run anywhere, right? I think that's Java that said it, but it applies to this as well. So again, thank you for watching, and I hope that I will see you again and that you will have found this useful. If you have any notes for me, please let them know in the reviews or comments, or send me a message on Udemy and I will take a look at it. I will try to keep this course updated with some more knowledge, better knowledge, more things that could be important for you to know. So check in every once in a while if you want. Again, thank you so much and have a great day.